So today we are going to see the simulation of the resistive load, and this slide shows you the circuit arrangement of the resistive load which is connected with the AC source, and here these two are in parallel. We are going to simulate these circuits in MATLAB, and basically this is the current and voltage waveform of a resistive load which is connected across the AC source. So by this slide we can see that the voltage which is indicated in the blue color waveform is in phase with the current withdrawn by the resistive load. So this is the theoretical concept, and theoretically the current withdrawn by the resistive load will be in phase with the voltage content of the source, AC source. We are going to check this with the simulated model. So for that I used MATLAB, and here MATLAB R2019A version is used to simulate the model. So here we have a option. So by clicking the new, so we have to open the Simulink model. So that Simulink model, when you are clicking that Simulink model, it will ask the opening of these windows, and we have to click on create model, and when we are clicking on this, so you can get this window. So by using this we can simulate the resistive load, and here the library is there. So in the library SimCap option and specialized power systems, you can find these elements or these tools and which helps us to simulate the resistive circuit. So for that I need a series RLC branch. So by adding this we can feed the resistor value, and I need a AC source to feed the resistive load, and we need measurements or measurement elements to measure the parameters. So now I am adding the AC voltage source with the opened model of window, and it is also added, and I need scopes to measure the voltage and current. So for that I need the measurement units. So here the measurement units is also available. So we need a current measurement block and voltage measurement block, and you can also use these three-phase measurement voltage and current if you are going for the three-phase Simulink model or three-phase resistive load. You can use this, and here the current and voltage measurements are enough, and we need a scope to see the waveforms, to see the voltage and currents waveforms. So for that I am adding the scope with the model. So everything is added with the opened model, and now I am rearranging the tools and elements. So I have separated everything, so it is added with us, and now we are going to convert this as a resistive load. So for that I chosen only the branch type as resistance, and here 10 ohm is added. So that 10 ohm is connected in series with the input source. Okay, so I connected this, and for that I need a current measurement. So I have to connect the current measurement in order to measure the current flowing through the circuit. So I am connecting these two, and I am connecting the output of the ammeter or the current measurements with the AC input source. And here I am connecting a voltmeter in parallel to the resistive load. So now I connected everything, and now I need two input sources, two input terminal scope to measure the voltage and the current waveform. So for that I am enabling it into as two input source. So now it is converted into a two input source scope, and now I can connect the output of the voltmeter and ammeter into the scope to measure the current waveform. And here I am not fixed the voltage rating and frequency of the input source. So here I am fixing it as a 230 volt and frequency as 50 Hz. So now I am applying the parameters. So now the simulation is ready to run, and if you we can add 100 ohm resistors or 10 ohm resistors, whatever you need you can add. So if you are varying that resistor value, so that will vary the value of this current. So 100 ohm resistor is added, and for running these simulations I need a power gate. So that is also available in the specialized toolboxes. So this power guide is needed to run this model. So I also added that to the Simulink model, and now I can convert this as a discrete or continuous. I need discrete, and 50 microsecond is the sample time. So that is enough for my simulation. So I have set, and now I am running the simulated model. So the simulation is running. When the simulation is running, you can see this progress of the simulation here. So once it is run, so now the model is executed. Now you can see the waveforms here. So you can enlarge x-axis and y-axis components. You can see that. So this is the current waveform. It is very low in magnitude, but the voltage is in higher magnitude. So we can increase the current rating by reducing the value of the resistor. So 5 ohm resistor I am adding, I am giving. So again I am running the waveform. So the model is ran. So now we can check some magnitude of the current. So here you see that this is the voltage waveform and this is the current waveform, so that both voltage and current waveforms are in phase with each other. So that waveform is coincide with the theoretical waveforms. So you see here, so this waveforms is obtained in the MATLAB model. Okay, so from that we can observe that there is no phase angle difference when you are connecting the resistive load across the circuits.